Hi all, in this video we are going to solve some of the problems which are coming under the activation functions. Okay, so let's see the question first. Calculate the output y of a 3-input neuron with bias. Okay, the input feature vector is given, that is x1, x2, x3, which is equal to 0.8, 0.6, 0.4. So there are 3 input nodes, that means x1, x2 and x3. The value is also given and the corresponding weighted values are also given, that is w1, w2, w3, 3 in weighted values, and also it includes the bias value, otherwise constant bias value is also given. So 0.2, 0.1 minus 0.3, 0.35 is the bias value. So you have to use the binary sigmoid function as the activation function. So in the question they are given that we have to use the binary sigmoid function. So there are two sigmoidal function. First one is binary sigmoidal and bipolar sigmoidal. If you are using binary sigmoidal, the range will be always between 0 to 1. That means f of x, the input value, the input that we are getting is given to the function which is a binary in sigmoidal function, that is f of x is equal to 1 divided by 1 plus e raised to minus x. And if we are using bipolar sigmoidal function, the equation is f of x is equal to 2 divided by 1 plus e raised to minus x minus 1. Okay. So in the case of a bipolar sigmoidal function, the range is always from minus 1 to 1. Okay. So this is the question. From the question, I draw the neuron like this. See, x1, x2, x3 are the two input nodes which are fed into the neuron. That is the output. This is from this node we are getting the output. This particular node consists of two functions, that means it performs two steps. One is summation part and the next one is the activation function. So first we have to find out this step 1. We have to find out the step 1. Step 1, what is the step 1? The equation for finding out the step 1 is summation. That means summation I equal to 1 to 3. Here how many number of inputs? 3 number of inputs. Okay, so I is varying from 1 to 3, wi, xi. Okay, so the value we have to add up with bias, because bias values namukku tannittunde. Okay, so x1 input, x2 input and x3 input, 0.8, 0.6, 0.4, and for each input value there is a weighted value also given over there. So for x1 its corresponding weighted value is 0.2, for x2 its corresponding weighted value is 0.1, and for x3 it's minus 0.3. And it is given the bias function, that means bias value normally it is 1 and the weighted value for the bias is 0.35. Okay, so we have to find out the y input, that means y input we have to find out. So y input is equal to b plus summation I equal to 1 to 3 wi, xi. So b, what is the b? B is 0.35, right? So b bias is 0.35 plus x1 into its corresponding weight, that means 0.8 into 0.2 plus 0.6 into 0.1 plus 0.4 into negative 0.3, which is equal to, after calculations we will get the answer as 0.45. So this is y input. That means the step 1 is over. This particular y input I have to given to which function? It is given that binary sigmoidal function. What is the equation of binary sigmoidal function? 1 divided by 1 plus e raised to x. Here x is our y input. Okay, so 1 plus e raised to minus yn, which is equal to 1 divided by 1 plus e raised to, the obtained yn is 0.5, so negative 0.45, which is equal to 0.611. So this is the result of this particular neuron. Okay, so next question is another problem. Another problem is draw the neural network architecture. I think this is the question which is asked in the recent supplementary machine learning paper. Okay, so draw the neural network architecture and calculate the output of the net based on the following input and weight value, and also using the activation functions binary sigmoidal and bipolar sigmoidal. So we have to find the answer of both the sigmoidal functions. So first it is given the input values, that is x1, x2, x3 as 0.8, 0.6, 0.4, w1, w2, w3 as 0.1, 0.3 and negative 0.2, and the bias it is given as 0.35. So this is our neural network architecture from the given values. Okay, so x1, x2, x3 it is 0.8, that means input value 0.8, x2 input value 0.6, x3 input value 0.4, and its corresponding weighted values 0.1, 0.3 and negative 0.2, and we are applying a bias also. So bias normally 1, but the weighted value of the bias is 0.35, that means bias is 0.35. How to calculate yn? Yn equal to b plus summation I equal to 1 to n wi xi. Here n is 3 because 3 number of inputs. Here n is equal to 3 because 3 input neurons. Yn equal to b plus w1 x plus w2 x2 plus w3 x3, which is equal to b is nothing but 0.35 plus first input value 0.8 into 0.1 plus 0.6 into 0.3 plus 0.4 into negative 0.2, which is equal to 0.53. So when we are applying a binary sigmoidal, first we have to calculate the answer from the binary sigmoidal. First, binary sigmoidal activation function y is equal to f of, that means f of yn, that means our x is here is what? Yn. So f of yn is equal to 1 divided by 1 plus e raised to minus yn, which is equal to 1 divided by 1 plus e raised to minus negative 0.53, which is equal to 0.625. Okay, calculate cheythu ningal nokkanam. And the second one is what we have to calculate. We have to calculate the output from the bipolar sigmoidal. So for the bipolar sigmoidal function, y is equal to f of n, that means the equation is 2 divided by 1 plus e raised to minus yn minus 1, which is equal to 0.259. This question is important, asked for 4 mark I think. Next one is calculate the this is also another university question. So calculate the output of the following neuron y of the activation function. Here it is given the network architecture, neural network architecture is given. We have to calculate the corresponding binary sigmoid and bipolar sigmoid. So here 3 input values. Input values are 0.6, 0.5 and 0.8, and the corresponding weighted values 0.3, 0.7, 0.5, and bias value is 1 and its weighted value is 0.1. Okay, so yn is equal to, we have to first calculate the yn is equal to 0.1 plus 0.6 into 0.3 plus 0.7 into 0.5 plus 0.5 into 0.8. So we will get 1.03 as answer. Next we have to apply the binary sigmoid. Binary sigmoid is, the equation is 1 divided by 1 plus e raised to minus yn or minus x. Here it is yn. So 1 divided by 1 plus e raised to minus 1.03, which is equal to 0.737. Next, bipolar sigmoid. Its equation is 2 divided by 1 plus e raised to minus yn minus 1, which is equal to 2 divided by 1 plus e raised to negative 1.03 minus 1, which is equal to 0.474. So this is how you have to perform its calculations. So these are the 3 problems which are coming under the activation function. Okay, so in the next video we can study another topic. Okay, thank you.